Although harmonic distortion is perhaps the most commonly measured distortion metric, it is often not ideal for measuring narrowband devices such as hearing aids and communication devices. These products often have a high-frequency cutoff around 3 to 5 kilohertz. So the high-order harmonics fall outside the passband of the device, so harmonic distortion measurements often underestimate the distortion. A useful alternative we offer in soundcheck is intermodulation distortion. Intermodulation distortion relies on the interactions between two simultaneous pure tones to produce measurable intermodulation products. These measurements actually present a more realistic representation of real-world signals such as speech and music that are rich with intermodulation products than a single tone used in harmonic distortion. Soundcheck offers two intermodulation distortion measurement options: intermodulation distortion and difference frequency distortion. For intermodulation distortion, we superimpose a sweeping frequency tone against a fixed frequency tone. For difference frequency measurements, we use a stimulus consisting of two sweeping tones separated by a specified frequency interval, which can be a fixed difference or a fixed ratio. These are fully customizable. In both cases, the two signals interact to produce intermodulation products. With intermodulation distortion, these are equal to the sum and difference of the upper frequency and integer multiples of the lower frequency. Difference frequency distortion only considers the components that are the difference and multiples of the difference between the excitation frequencies. Each type has its own specific applications. For example, intermodulation distortion is mostly used for loudspeaker measurements, particularly at low frequencies, and difference frequency distortion is ideal for testing narrowband devices, as the frequencies can be chosen so that the intermodulation products mostly fall within the passband. This is easy to do in soundcheck. Simply configure your two test stimuli and select your analysis, either intermodulation distortion or difference frequency distortion, in the analysis editor. Intermodulation distortion is also a valuable technique for measuring microphones. Usually the harmonic distortion from the source speaker playing the test tone is greater than the harmonic distortion that you're trying to measure from the microphone. However, if separate test tones are fed individually to two separate loudspeakers, the loudspeaker's harmonic distortion has no influence on the measured intermodulation frequency components, enabling accurate measurements of the microphone's intermodulation distortion. To learn more about intermodulation and other types of distortion, check out our website and stay tuned for a new in-depth seminar on distortion.